Okay, so I'm going to look at another example of using Newton's method. So the question says complete 2 iterations of Newton's method for the given function and indicated initial guess. There's my function. It's a more complicated function than the last one we looked at. The last one we looked at was f of x equals x squared minus 7. Again, look at that one again before you try this one out, just to get the basic idea of the shape of the kind of answer to these questions. We're going to go for 2 iterations and we're trying to approximate the root. The root here is not obvious. Okay, we're going to be using the formula for Newton's method, which says x sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. Okay, these are successive approximations for the roots of the function. Okay, one thing on the bottom here, we have to know the derivative of the function. So if I take the derivative of this f prime of x, the derivative of 1 is 0. We might just factor out that negative 1 and take the derivative. Product rule here, the first x times the derivative of the second, e to the power of x, that's x times e to the power of x, plus the second e to the power of x times the derivative of the first, which is just 1. Okay, so I'm just tidying that up. I can factor out the e to the power of x, and it multiplies by x plus 1. Okay, so that's the derivative of the function. Now we're ready to apply Newton's method. So Newton's method says, for my second approximation, remember my first guess is x sub 1 equals 2. Maybe somebody's told me that there's a root in and around 2, or I'm just making a really good guess. There's a root in and around 2 here. So x sub 2 is going to equal to, well, from my formula, it's x sub 1 minus f of x sub 1 divided by f prime of x sub 1. So what's x sub 1? Well, x sub 1 here is my first guess, which is 2. We think there's a root in and around 2. X sub 2 is going to be closer to the root. That's the idea. So we're going to get f of 2 all divided by f prime of 2. Okay. So it's 2 minus f of 2. F of 2. Well, plug 2 into the function again. 1 minus 2 times e to the power of 2. 1 minus 2e squared. All divided by f prime of 2. Well, f prime will be negative e squared times 2 plus 1. Which is negative 3e squared. So I'm getting 2 minus 1 minus 2e squared on the top, and on the bottom I'm going to have negative 3e squared. Okay, and I could write that as a single fraction. And watch out for this negative sign in the middle. If I write this as a fraction with negative 3e squared on the bottom, well, this would become 2 is the same as negative 6e squared divided by negative 3e squared. And then we'd have subtraction of 1. And I'm also subtracting this negative. That's going to be a plus 2e squared. So that's going to be negative 6e squared plus 2e squared. That's negative 4e squared minus 1 all over negative 3e squared. Okay, and we can get rid of all those negatives that we don't really like. That's just going to be 4e squared plus 1 divided by 3e squared. Now I am going to plug that into my calculator. 4e squared plus 1 all over 3e squared. And I'm getting about 1.38. Let's just round it off, say to 2 decimals. That's approximately equal to 1.38, if my calculations are correct there. Okay, so you can, that's my second, or my first iteration. My first guess is 2. Through one iteration, I've got a better approximation at 1.38. Okay, so I think there's a root in and around 1.38 for this function. Okay, so I'm going to improve on that again by looking at my third approximation of the root. And that's going to be x sub 2 minus f of x sub 2 divided by f prime at x sub 2. Okay, x sub 2. And again, we're going to use 1.38. It's a better approximation. Minus f of 1.38 all over f prime of 1.38. So we get 1.38 minus f. Well, the function f set is 1 minus whatever x is. 1 minus, in this case, that'll be 1.38 times e to the power of x. E to the power of 1.38 all over f prime of 1.38. That's going to be negative e to the power of 1.38 times x plus 1. That's 1.38 plus 1. And I'm not going to bother doing any mental arithmetic here. I'm just going to plug all that straight into my calculator. 1.38, subtract a fraction bar on the top and put in 1 minus 1.38 times e to the power of 1.38. And on the bottom I'm putting in negative e to the power of 1.38 times 1.38 plus 1. I'll just put in 2.38 into my calculator. And that's giving me 0.906, say, around 3 decimal places. So that's my next approximation. So my first guess was x1 equals 2. My next guess is x2 equals 1.38. My next guess is 0.906. To find another guess, I would just say x4 is going to equal to x3 minus f of x3 divided by f prime of x3, etc., etc. Okay, plug x3 in there. To find the fifth approximation, x5 would be x4, subtract f of x sub 4 divided by f prime at x sub 4, etc. Okay, so that's how to use Newton's method to find successive roots in here. I just want to make sure. Yeah, 2 iterations. That's all I was asked to do. So, but I can do as many as I want following that same process. Calculator is pretty handy for this. It's not quite as easily done in your head as the last example.